Today we're going to be talking about the electric field and how that electric field relates to equilibrium and force with electric charges. Here's some just symbols that we will use. You'll see quite often. We've already talked about this. What I'd really like to get into here is specifically with force and equilibrium and how that works with charge. Well, we know that the equation for electric force is K times Q times the other charge over R squared. And it's going to give us the same thing on the other side. Now, equilibrium means that two forces are the same. And I kind of did this a little bit out of order, but we'll go back to backtrack a little bit here. Let's say I have a charge here. Call this Q1. And I've got another charge over here. Sometimes it'll be positive, sometimes it'll be negative. And let's call this Q2. But it doesn't matter what charge I place in here, whether it's positive or negative. At some point, it would be in equilibrium. I'm going to put an N here for neutral. It won't ever be neutral, but it can be any charge. At some distance from these other two charges, it's going to fall into equilibrium, meaning that the force of attraction or repulsion here would be equal and opposite in direction over here. So if we had, let's say, let's go ahead and make this charge 3 here be a positive charge, then Q1 is repelling it. And let's go ahead and say that it was repelling it with, I don't know, 0.01 newtons. Then some distance over here, at some distance between these two, they would fall into equilibrium as well if the force was 0.01 newtons over here as well, pushing on it. And there to make that a plus. So what we find out is that charges will fall into equilibrium when the forces acting on this third charge, this middle charge, is equivalent. And it doesn't always have to be in the middle. I think it will be for all of our examples. So what I'm going to add here then is we're going to say the force on 1 acting on charge 3. Or let's backtrack on that. Let's say it the way we would have done the other day. The force on 3 due to 1 is equal to the force on 3 due to 2. And now we have our equations, and this becomes charge 3, charge 1, charge 3, charge 2. What I want you guys to understand is that a lot of times there's going to be a lot of things that cancel out. For example, Coulomb's constant, it's the same on both sides, so it's going to cancel out. If you have a charge that's the same on both sides and you're not trying to find it, then it'll cancel out. So in this case, Q3 is canceling out. It's going to cancel out here. What does that leave me with then? Well, that leaves me then with, and this isn't always the case, but the charge on 1 over this distance squared, and that would be the distance from 3 to 1, is equal to the charge on the second one divided by the square of the distance between the third charge and the second charge. So we have lots of subscripts and subscripts with this, and that's confusing for a lot of students from time to time. Once again, the reason that some of these were able to cancel out, the K constant, because it's just simply the same. That's almost always going to cancel out. I can't think off the top of my head of a time it won't. Charge 3 is going to cancel out because it's the same in both cases. Alright, so on both sides, it's going to cancel out. So what we're looking at here is we're able to either find, we have 4 variables, and we have to have 3 of these variables that are supplied to us. As long as 3 of them are supplied to us, we can always solve for the 4th one. So So let's look at our first example here. I'm going to go through here and create a list. Okay, what I've done here is I've went ahead and included all of the dimensions here. All of the information, not the dimensions, the information that they give to us. I've said that Q1 is 3 times 10 to the negative third coulombs. I've said that Q2 is 2 times 10 to the negative third coulombs. And I've said that Q3, a third charge, so that's telling us it's Q3, is negative 4 times 10 to the negative third coulombs as well. I then went ahead and they told us that the distance between 1 and 3 is 2 meters. So I said the distance, or the radius, between 1 and 3 is 2 meters. They want to know, how far is Q3 from Q2? Well, we can say then that the force, in this case, of 3 on 1, due to 1, is going to be equal to the force of 3 due to charge 2. And then what's going to be subscripts, although it be confusing maybe now, do allow us to keep this information a little bit more organized. The K's are going to cancel out, so I'm not even going to write that. What else? By looking at this, what other charge is going to cancel out here? Well, 3 isn't common in both cases, so I see Q3 is going to also cancel out. So I'm going to simply write this as Q1 over the distance squared is equal to Q2 over the distance squared. When I plug this information in here, I get 3 times 10 to the negative third over the radius squared, where the distance between 1 and 3 is 2. 2 squared is 4. And the charge of number 2 is 2 times 10 to the negative third. And the distance between 2 and 3, or 3 and 2, we don't know yet, so I'm going to put r squared there. I think we had a long pause there. Maybe you guys found it there at that point. I hit a wrong button is what I did. But what we get is we can treat this like a proportion and cross multiply. That gives us 3 times 10 to the negative third times r squared equals 8 times 10 to the negative third. When we divide by 3 times 10 to the negative third and then take the square root of both sides, we find out that the radius is equal to 1.6 meters. What I've done here is I've already created my list. If we look in here, it wants to know what is the charge of Q1. So there's my Q1. I don't know what it is yet. It tells me that my first another stationary charge, call it Q2, and then I've went ahead and identified Q3 here. The distance between 1 and 2, they tell us, is 4 meters. Alright. They then tell us the distance between 1 and 3 is 2 meters. Henceforth, the distance between 2 and 3 also has to be 2 meters. So when I go to set this up, again, now, I'm going to have the force is equal to the force. And what we find out here is the force on 2 due to 1 is also equal to the force of 2 due to 3. As I look at these again, which one's going to cancel out? Q2, because it's on in both cases. So I'm simply going to write Q1 over R squared is equal to Q3 over R squared. That leaves me then with Q1 over, where the radius between 2 and 1 is 4. 4 squared is 16. The charge of 3 is negative 4 times 10 to the negative third. The distance between 2 and 3 is 2, so 2 squared is 4. When we cross multiply and then solve it like a proportion, and when we divide and square roots, actually is what I mean, you're going to find out that the charge on Q1 is equal to negative 1.6 times 10 to the negative second coulombs. I want you guys to go ahead and take a second and try to work this one out. Alright, I'm back. If you can tell in this case here, I didn't give you the answers this time. We'll go over it in class if you have a question on it. Alright, go ahead and give this one a try. Very similar to the second story problem that I had done. Alright, that marks the end of today's notes. I hope you're able to understand. I know you're going to have lots of questions. I'm fully expecting that. I'll see you tomorrow. Have a great evening.